Hi guys, today you're going to do a little practice with reading activation energy diagrams, and we're going to look at this more next week as well. I did this two ways. The first way I did put it into Kami. Now I know some people's computers may not load Kami correctly or what have you, and I'm not all that well versed in dealing with Kami, so if you are having issues with it, please reach out to Mrs. DeMarco. She should be able to fix any problems that you're having. But in the meantime, I also included it just as a document. So if you click on this link up here, it should download it to your computer and then you'll be able to view it that way. I believe you'll have to create a separate document and probably email it back to me to turn it in if you do it that way. Ideally, it'll pop up looking something like this. You might have to allow it access to your Google Drive and there would be a button in the middle. It would prompt you to do that if you need to. So when you're using Kami, you want to have this tool highlighted over here that's a text box, and you will just click somewhere on the document and you'll be able to write. So the first question here, looking at the graph to the right, what do the letters represent? So if we're looking at letter A, we're talking about the beginning of the reaction here. What is the beginning of the reaction called? Well, those parts that are reacting are called the reactants. So I would type in reactants there. And then you would need another text box for B. So B is referring to this arrow that goes up and down. That's going to be your activation energy. Now if you notice as I'm typing, these letters in my boxes are not exactly right where they need to be. So you can move the boxes around so that it fits better. Please do that. If you have writing randomly all over the place, I'm not going to know what question you're answering. The last one is part C, which is referring to the ending part. So after you have your reactants, and the reaction takes place with the activation energy needed, and the reaction is finished, you have your products at the end. And I can move that little box over there so that it's more in line. Okay, moving on down. How much activation energy is needed to start the reaction? So you would need to do some math, potentially. Looks like it has to reach 120. And it's down here at 0. So 120 minus 0, it's going to need 120 kilojoules of energy. The next one, specify whether each reaction is exothermic or endothermic. The reaction shown in the diagram above. So in order to determine if it's endothermic or exothermic, you need to see where your reactants began and where your products ended. If your products are higher than your reactants, the reaction is endothermic, meaning that it took in energy. If your products are lower or below your reactants, then the reaction is exothermic, meaning that they gave off energy. So looking at this one up here, I can tell that my products are definitely above my reactants. So that means that this reaction took in energy, making it endothermic. When the reaction takes in heat to produce products, so if it's taking it in, we know that's endo. The reaction gives off heat to produce the products. If it's giving off heat, so that is going to be exothermic. And I'm just going to do a few more questions just so you guys get the idea of what you should be looking at. What would happen to the graph above if a catalyst were involved? If a catalyst was involved, okay, so we know catalysts are going to decrease activation energy. So here's my activation energy. If a catalyst were involved, I wouldn't need 120 kilojoules of energy. So the reaction might take place at 90 or 60. So I would say that I need less activation energy. I don't know how much less. It would depend on the type of catalyst that were involved. Answer the following questions based on the energy diagram here. Does the graph represent endothermic or exothermic? So here's my reactants and here's my products. My products are definitely below my reactants, so that means that this reaction here would be exothermic. Now how did I choose that answer? Well, I saw that the products were below the reactants. Determine the activation energy for this reaction. Okay, so I start here at 60. Looks like it goes up by 20s. So 60, and I'm trying to get to 120. So 120 minus 60, that is 60 kilojoules. How much energy is released or absorbed during the reaction? So energy is being released because we know this is an exothermic reaction. It started at 60 and I'm down to 40. So 20 kilojoules would be released. It has been observed that more gas station fires occur on hot days than cold days. Explain this phenomenon to the best of your ability. Well, think about what occurs or what needs to occur in order for a reaction to happen. Normally you have to have the correct environmental conditions, and we know that heat is going to cause reactions to take place faster. So if it's a really hot day, that heat, that air, the sun, is going to act as a catalyst to push for some type of a reaction to occur. So the heat will act as a catalyst. So that heat will be there on the hot days. It's not really going to be there on the cool days. 7, 8, 9, 10. So there's only a couple questions left, and I'm not going to do those ones for you since I went through and did the first couple. But the next ones are pretty much all exactly the same. So you're looking at this energy diagram here, and you're going to be kind of doing the same questions that we did here in number 5. Similar answers. Some of them will be endothermic, some will be exothermic. It just depends on, where your products are in relationship to your reactants. And you have to do a little bit of math. Once you guys are finished, you want to hit the Save and Submit button up here at the top, and that should send it back to me. Alrighty guys, have a great day, and I will talk to you later.